Hello everyone, my name is Gabriel Cantareira and I will be now presenting the paper Exploring Interpersonal Relationships in Historical Voting Records for Eurovis 2023. This presentation will cover an implementation of a visualization toolset alongside humanities experts, starting with our motivation and design goals, then going through the tools themselves and ending with user studies and our findings. Our work is associated with the Quill project, a research initiative focused on maintaining well-organized datasets from foundational legal texts and constitutional conventions for text analysis and data visualization. It is intended for humanities academics and scholars for purposes of research and teaching. Therefore, there is a need for tools to aid in exploring and investigating large datasets for historical negotiations. These datasets often include voting records, detailing events that require voting by the attending participants, from accepting amendments in legal texts to procedural decisions such as creating a committee. The image on the right side shows a few screenshots of the Quill platform, detailing its description, a few of the available datasets, and the event timeline for a given session from a convention. Using visualization methods to analyze voting records is a somewhat well-established concept, as political scientists have been making use of visualization approaches to aid in understanding their data for a few years. Either for research or learning, visualization can provide a deeper understanding of the political landscape of a given historical moment and provide insights on political relationships and alignments. In the particular case of Quill, domain experts wanted ways to explore and interact with voting data in a way that would not depend on historical context and would make use of other data available in the platform to enhance analysis. One of our main challenges was dealing with unstructured temporal sampling. Voting data analysis often is based around historical events, such as comparing data between terms for different presidents. To fully enable exploratory analysis, we need to allow users to also follow the inverse path, providing tools for them to interact with the dataset and finding relevant timespans to observe on their own. A second challenge was to work with the wealth of additional data in Quill and understand what else can be shown to enrich representations for voting data. Finally, the way existing interfaces in the system operate and how users interact with them should also be taken into account for consistency. Our design and development process was as follows. We maintained close and frequent communication with a lead domain expert, who would identify domain requirements and give feedback to individual components as they were conceptualized and developed. At certain milestones in the process, we also conducted feedback sessions and evaluation with multiple experts, as to refine and revise both the set of requirements and tool design. Eventually, we condensed domain requirements down to 4 elements. The ability to conduct exploratory analysis over voting interactions, allowing users to filter and compare data, the ability to obtain insights on roles and behavior of individual people, providing direct access to event and person data when requested, even if you use abstractions and representations, the data itself should be readily available, and properly integrate the tool with other Quill interfaces. Quill has interfaces for exploring elements such as events and keywords that should be linked when necessary. Beyond that, we also needed to ensure that tools were developed consistently with other interfaces in terms of usability. Quill datasets have several interconnected components, and preparing data for a visualization application usually involves building data instances from the desired information from its relational database. The negotiation of text is represented as an event-based structure that can be followed as a hierarchical timeline. Multiple events occur within a session, multiple sessions occur as part of a committee, and multiple committees form a convention, which represents the entire dataset. At the same time, we have other entities, such as people, documents, and keywords, that can be linked to any entity in the event hierarchy, such as an event indicating a person who made a speech, and the list of all people that formed the committee. There are multiple types of events in Quill, but the most relevant here are decisions. They represent events that require voting by the attending participants. Each event decision contains a voting record. Some of them may contain records for individual votes cast, but others don't. This can be due to several factors, such as a vote being marked as anonymous, simply described as unanimous in session minutes, or simply unavailable data. Certain historical records may not be complete or fully digitized yet. Mathematically, we can represent votes as either -1, 0, or 1. 1 is for votes for, -1 is for votes against, and 0 is for either abstention or absence. When we look at votes over an extended period of time, we can represent votes as an n by m matrix V, where n is the number of voting people and m is the number of decisions in that time span. We use this matrix to generate multidimensional projections and calculate distances between voters to illustrate their relationships. Our visualization system consists of two interfaces, a dataset visualizer and a person visualizer. The dataset visualizer contains analytical tools for navigating all voting in a convention dataset and finding relationships, trends, and points of interest in general. If one or more of the voters draws user attention due to their behavior, the person visualizer can then be assessed to display detailed information on person activity at an individual level. The goal was to establish an exploratory analysis workflow. Users would form hypotheses by observing voting behavior in the dataset visualizer and then verify them using the person visualizer. The two interfaces are linked to other relevant interfaces in the system, such as pages for exploring events, sessions, and committee. The image on the right side illustrates these interactions. The dataset visualizer is an interface consisting of a timeline view, a scatter plot, and a chart panel. The timeline is used to provide an overview of the dataset and allow users to select a subset of decisions as a sample. The vote matrix containing all voters and all decisions within the sample is then projected using PCA, so that relationships between people can be observed. Finally, the charts contain information about the PCA plot itself, so that users can have more context as to the meaning of geometric positioning in the visualization. The timeline view shows all decisions in the dataset, grouped by session. Each session is shown as an orange dot, and each decision is another dot above a session. Decision dots are colored according to the availability of individually cast votes that can be used in the PCA projection. Decisions with available votes are colored blue, while decisions without them are colored gray. The timeline can be filtered to include only decisions belonging to certain committees or that refer to specific documents, and navigation options such as zooming and panning are provided. Detailed description for the contents of each session or decision can be shown on demand. Users can then sample the timeline for projection. The interface allows the selection of a secondary sample simultaneously, so that relationships in two different time spans can be compared. Once samples are selected, they are projected as a 2D scatterplot using PCA, with each dot representing a person's votes. If a secondary sample was selected, it is shown in transparent red. Toggle options are available for displaying dots from the same people in the two different samples, or connecting them with arrows depending on their distance, to further emphasize changes between projections. People names can be toggled on or off, and descriptions are provided on demand by clicking or hovering. The two projections are aligned as best as possible by applying Procrustes analysis over the secondary projected sample. One important point was to make users aware that spaces between the two projections are still not inherently comparable, and distance variations between the two projections are not guaranteed to be meaningful, serving only as a tool to show possible points of interest to be investigated further. We employed PCA as a projection technique due to feedback received from domain experts, who were particularly interested in it being a linear method. Spatial positioning could be explained and traced back to the original dimensions, which was considered valuable. To keep users aware of projection quality, we showed the explained variance of each component below the scatter plot. Continuing this thought process, the interface also includes charts further explaining a projection, showing the absolute values of coefficients for each component. This allows users to identify the impacts of each decision in determining the position of points, the relevance for separating the dataset, or if some of them are correlated. Other options include the ability to see how many non-zero votes were recorded at each decision. The Person Visualizer is an interface designed to show detailed information about a person's activity in the convention. It shows their participation in committees, interests, relationships and alignment, activity, and voting records. We obtain data related to a person by querying SQL databases, looking for either elements directly related to a person or elements related to events in which that person appears. The first component is the participation panel, which shows reports of the person's activity in each committee. For each committee, we display a donut containing the number of events involving the person and the relative amounts compared to the event total in that committee. Users can click one of these reports to focus the Person Visualizer in information concerning that committee in particular. The second component is the Keywords panel. Although Quill allows for keywords to be assigned by editors to events, people, or committees, not all datasets currently have keywords available. In these cases, we generate them automatically by using Yake. Keywords can be seen either in word cloud format or as a chart that directly displays their scores. Users responded positively to the word cloud. The third component is the relationship panel, which takes voting information from the entire dataset to generate a projection of the voter's neighborhood and a list of the closest and most distant people to them. The neighborhood map is generated using TSNE. During feedback sessions, users stated that they would rather have the closest dots in the map actually match the top 5 list as often as possible, in which a nonlinear technique showed generally better results. Alongside each person in the top 5 lists, their distance to the selected person is displayed. To avoid issues in the cases of people that had different levels of participation or that attended to different committees, we use a normalized distance that takes the number of non-zero votes from each person into account. The two remaining components are activity and voting breakdown. The activity panel shows a list of all events in the dataset, grouped vertically by session and filtered by committee. Each event is then displayed in a horizontal list of icons, which are the same event type icons that are used in other existing interfaces in Quill. Event icons are shown in different opacities. Events in which the person has participated are shown in full opacity, while other events are shown as semi-transparent. The voting breakdown is the last component and consists of a scrollable bar chart with all decisions in the dataset laid out vertically in chronological order, grouped by session. Using different styles of bar, we display the total amount of each type of vote per decision, as well as highlighting which one was chosen by the selected person. The descriptions and final outcome for each decision are also displayed. Additionally, users have the option of selecting another person to compare votes, allowing users to observe exactly when agreement and disagreement happen. Our interaction with users consisted of ongoing feedback from our lead domain experts and evaluation sessions with multiple other experts. We performed 3 rounds of evaluation at different milestones. Once we had a prototype for the dataset visualizer, once we had a prototype for the person visualizer, and once we had done refinement changes to both of them. The first evaluation was an inception workshop, which focused on the dataset visualizer and included 7 participants. The second evaluation was a survey, focused on the person visualizer, which had 10 participants. The third evaluation consisted of one-on-one interviews, focused on evaluating the ensemble of both interfaces. Participants were exposed to the tools and asked questions in conjunction with the Think Aloud protocol. The interviews had 5 participants. All participants were humanities experts that worked with Quill for at least a year. The purpose of these evaluation sessions was to gather feedback on the usability and efficacy of the tools, as well as to diversify our sources for feedback and avoid potential bias from our lead expert. Overall user feedback for the toolset over the 3 evaluation rounds was generally positive. Here are a few of our findings that could be relevant, not only for this domain but for applied visualization research in general. There was a distinct division between feedback from users who were familiar with PCA and users who were not. Familiar users would be interested in observing more details and statistics about the projection, while users who were not familiar gave feedback suggesting that they would rather have less information shown. Still on the subject of familiarity, the event list on the activity panel consistently received the most praise, despite showing certain scalability limitations. Users often praised its use of recognizable icons from other Quill interfaces. Another interesting point of discussion was that we originally used PCA for both the dataset visualizing and the neighborhood map in the person visualizer, but users reported confusion if the projection would not match the list of closest people in the same panel. They would rather have the 2 things match even if using a different technique than the one used in the dataset visualizer. Lastly, while there are known trade-offs between using simple or familiar representation versus more efficient ones with a steeper learning curve, there are varying levels of efforts that different users are willing to put in to operate a visualization tool depending on their circumstances. And discussing this with each domain expert available may provide valuable insights. Thank you for your time in watching this presentation. This slide contains contact information. Goodbye.